Here is our assembly of two 1x1 bricks of Legos, familiar Legos. And I want to find out whether or not these two parts fit together. In other words, in the electronic world of the computer, I have put these two together and they seem to fit. But are they trying to occupy the same physical space at the same time? There's a way to determine if that's the case, and to do it, we can use the interference analysis tool. So let me get this situated so that we can kind of see, let's see, maybe like that, so you can see it's at an angle. So I'm going to click interference analysis, and it says define set 1 and then define set 2. One of them is highlighted, so that means it's waiting for me to define the set that I want to analyze, one of them. Set just to me stands for parts at this point, so I'm just going to select this point, that part, and then I'm going to come over here and select that part, and then I'm going to say OK, and it says there were no interferences detected. Okay, alright, fair enough. So you might remember that we had a square in here, and I kept saying, if you've watched the previous videos, the diameter of the square as 4.8 millimeters. Well, the length of each side of the square was 4.8, and the radius of our stud on the green Lego was 4.8, so it should fit, right? They're identical. In real life, you might want to add a few thousandths of an inch so they fit together, but for now we'll keep them the same. Now I'm going to show you something here. I'm going to right click on the mate constraint, and I'm going to edit it, and I can do an offset. So I'm going to offset it by, okay, we're in inches. Why are we in inches? I think I can just say, put in units, by 5 millimeters. Okay, so you can see, you can separate them out by modifying the constraint. So the constraint becomes a discrete item over here in the side window, and it is there to help you kind of understand what's going on. And so we are going to now analyze things to see how much room we have. We're going to shift the green one with respect to the red one, and we're going to see that this stud will start to try to occupy the same physical space as this Lego body. And I want to show you how that is illustrated in Inventor. Okay? So right click done. I'm going to undo the separation, and so it's 0. So now they're together. So I am now going to I'm going to go to one of the flush constraints. Let's go to the top one, right? That flush constraint says that these two faces are parallel. I'm going to right click here. I'm going to edit it, and I am going to shift or modify the offset between that constraint by a very small amount. I'm going to say 0.5 millimeters. Notice how I can, well, that's too much. That's obviously not going to fit. So edit, and let's see, 1,000th of a millimeter is a micrometer or a micron. I don't think this will take microns as a unit, so I am going to, instead of 0.5 millimeter, I'm going to say, let's see, how about 0.02 millimeters, 20 microns. And as far as we can tell, they fit together just like they did before. So what I'm going to do now is interference analysis. Click that guy, come over here, click the other arrow, click that guy, and OK. and you can see, uh-oh, total of 1 interference was detected with a total volume of what it says there. So what happened was that we tried to move it over a bit, 0.02 millimeters or 20 micrometers or microns, and you can kind of see what, if you think about it, this is what you would expect. That cylinder is starting to invade that square area or get out of it, and you can see just the tip of that cylinder. So let's make that a little bigger. Let's make it 50 microns or 0.05 millimeters. Still looks like there's no issues there, just eyeballing it from a distance. But if we do our analysis, we will see that, oh, okay, it's starting to grow. So we're really starting to slide it over. Let's do it one more at 0.1 millimeters. That still kind of looks like it's okay. Analyze here, and okay, and you can see it's starting to really come out. And just to beat a dead horse and really go at it, let me take it over 0.3 millimeters. Very obvious that it'll be off center. So you can see that I'm sliding the black one now to our left, and so the stud of the green one is invading the solid space of the black one, and you see the black area there, and it actually tells you the volume and stuff like that. So that's a way to do interference analysis and then assembly.